Yeah, okay. Keep saying it encountered a problem.
Well, I guess live stream is just not going to have your slides. It's all good.
Turning it off and back on again.
It's all good. We'll get the slides up afterwards.
Where are we? Is there a... I can point the camera at the screen.
I got the screen on this camera. You're good. Just go with the presentation.
All right, cool. I don't know what else I can do. You're in this video call. Yes.
That guy looks familiar.
Yeah.
Share screen. Does that work? You are screen sharing. Says it's working. All good?
Yes.
Yay! All right. Hi, everybody. I'm Jason. Hat or no hat? I couldn't figure this out. Hat works? All right, we're going to go with the hat. I'll try the second half since we're going to break for pizza without the hat and see how we go. Exactly. All right, so this talks about Docker. It's kind of an intro to Docker, but we are going to do some live demos. We're going to talk about what Docker is, how it works, why you want to use it. We are not going to talk about how to launch it in production, and because that involves like training wheels and all sorts of crazy things. We might have a follow-up talk on that sometime later in the year with like Kubernetes and all those kind of things. We will touch on it briefly. So a little bit about me, Jason Doherty. I'm a solution principal at Slalom. I work here basically. Software architect, 20 years in software development. Started my own company. Don't do that, it's crazy. Been a VP of product as well, so I understand what the product people do. Listen to them, they know what they're talking about. I'm into IoT, sensors, machine learning, all sorts of nerdy stuff. I also build guitars and tube amps, and I'm a musician. That's me, that's our website. Come see our band, we're awesome. All right, our agenda for today. So Docker basics, images, containers, and registries. We're going to talk about what that kind of stuff is. We're going to compare containers versus virtual machines. We're going to look at installing Docker. We're going to do a demo of starting a database, services, networking, and how that works in Docker. We're actually going to build a little sample microservices project in Docker Compose, and we're going to look at container orchestration. I'm going to try to do all that in 1 hour. Okay, so what is a container? Docker is basically a container. It's a thing that you can run stuff in. So I could run MongoDB in the container, I could run Node.js in the container, or I could run Python in the container. It turns out I can run basically anything that I want inside of a container. The nice thing about things like Docker is I can take a single host machine, and this is different to virtual machines, and I can run multiple containers and then run multiple different types of software in those containers on one machine. Or I can run them on a whole fleet of hosts and run a whole fleet of services inside of those containers. So why Docker? It avoids the works on my machine principle. It's predictable. If you install something with Docker, you can run it anywhere, and it basically runs the same way, unlike virtual machines. It's easily auto-scalable, so you can run one container, oops, need to run 10, oops, need to run 100 to cope with the load, so you can scale up easily. It's portable, so I can pick up my containers, run them on my machine, run them in the cloud, run them in a different cloud, run them on-prem, works the same way everywhere. Secure. Docker has much better security than virtual machines as a general rule. That's not always true, but I'm not going to talk about it a lot. You can leverage community solutions. We are going to talk about this quite a lot. So there's lots of industry standard things out there that are available in Docker. And we can create complex solutions like microservices. And we're going to talk a little bit about microservices in this talk today. So some Docker terminology. These are the words that you will see as images, containers, tags, registry services, ports, networks, volumes, Docker Compose. We're going to cover all this stuff today. Who has used Docker before? Hey, look at that. Almost everyone. Yay, cool. All right. So a Docker image is like a template. So an image is defined by a Docker file, gives you a base OS version. You can pick which libraries you want. You install your application code. You do configuration with ports and environment variables. Then you have startup commands for basically how to start your container. It's all bundled together into a pre-built image. So you can start with something like Debbie and Jesse, like a Unix variety as your base image. And then on top of that, you can install the latest Node.js versions. You can install NPM packages. You can copy your JavaScript code in. You can run your startup commands and then expose ports and storage. So what that looks like is something like this little snippet down here, which is an actual Docker file. And it basically does all the things that you see up there. And we're going to write Docker files and do all that kind of goodness as part of this talk. So a container is an instance of a Docker image. And it's basically a cookie cutter kind of thing. So a host can run multiple containers, and therefore a host can run multiple images inside of that, inside of each one of those containers. And then we have this concept of tags, which let you select specific image versions. So an image would be something like Mongo. And the tag would be latest or 3.4. And you want to do these kind of things because when you're doing upgrades in production, you don't want to suddenly get hit by a different version of something and something else. So the nice thing about Docker is it lets you predictably say which versions of things you want to link in over time. So the Docker daemon, basically, or daemon, I don't know how you say that. I say daemon, whatever. So you've got a host machine, it runs the Docker daemon. Docker containers run inside of that daemon. You can kind of run whatever you want inside of each one of those different containers. And then you have the Docker CLI either running on the host machine or on your laptop, which connects into the Docker daemon and then can run commands against it to do stuff, like pull down a new image or build your own custom Docker file or run a custom Docker file. And we'll do all of this stuff later in the talk. So container registries, the biggest one by far is Docker Hub. There's a lot of other ones, and if you work with enterprise customers, you'll find a lot of them have their own, and you will be forced to use theirs. And that's when life gets really interesting. Because now you're basically not allowed to use Docker Hub, but you want to be able to pull things from Docker Hub, and you'll spend most of your time figuring out permissions for things. But Docker Hub has a huge library of pre-built Docker images. It's got common applications pretty much available out of the box. We're going to use 2 of them today. It's got pre-built images for running most languages. It's got most operating systems, so Ubuntu, Debian, CentOS, Fedora, yada, yada, yada. But pretty much everything that you want to run is available as a Docker image. So far, I haven't found anything that wasn't available in Docker other than my own app code. So the kind of summary of how this ecosystem works, and this is a graphic from the docker.com website, is you've got a Docker client running the CLI. It runs various commands against the Docker daemon. It tells the Docker daemon to go and get things from the Docker registry, and then it downloads those images to the local machine, and then you spin them up inside of containers, and they run isolated inside of containers. All right, so quick demo of how to do this. So, see if the demo gods are with me. So right now what I'm going to do is I want to basically pull down MongoDB. So I'm going to go docker pull Mongo. And what that's going to do is connect to docker.com. It's going to download MongoDB onto my local machine. And pay attention to how it's doing it, because we're going to talk about this in a minute. All finishing, yay. Need hold music, should have brought my guitar along. All right, and now I'm going to go docker run D to run it as a daemon in the background. I want to expose it on a port, so I'm going to go port 27017, which is the default Mongo port. Mongo, bingo, it's run. And now I should be able to connect to MongoDB if the demo gods have smiled on me. And now I actually have my own MongoDB database running. Now compare that to what running a Mongo database used to be like. And Mongo's easy because they actually have pre-packaged things like brew installs for doing Mongo. But if you get something like ActiveMQ or something like Redis, I mean, actually Redis is pretty easy to install, but something like ActiveMQ or Kafka, you can download Kafka and run Kafka in like 30 seconds. Somebody before was blaming Kafka for our pizzas not being here, so they weren't using Docker, clearly. So if you want to see what images you're running, you go Docker images, and these are all the images that are downloaded, and you'll actually see that I've got Mongo, Node, Python. I've got these Kubernetes ones in the background. Ignore those. Pretend they're not there. et cetera, et cetera. So that's basically what's running in the background. So if I want to kill that service off, I have to go Docker PS. That'll actually list my running images. I find my container ID of Mongo, and I go Docker stop, and that'll kill that one off. So now I don't have Mongo anymore, so if I come over here and try to actually refresh my connection, Mongo's gone. That simple. All right, so any questions on that so far? Yep.
So when you do Docker pull Mondo, like that could be any other language or framework you're dealing with for the most part?
Sometimes, yes. We'll actually show, I've got a whole slide that covers how you build those things up and what they cover and what they don't cover later on. But yes, you can get like a runtime environment for running Python, for example, or a runtime Node.js environment that's already pre-built. And we'll actually use one of those in part of the class. Cool. So that's pretty much all we did was those commands got us up and running with Docker. When you get the hang of Docker, you wouldn't want to work any other way. All right, so most people are generally familiar with the concept of virtual machines. So in a containerized application, what you have is the infrastructure and the host operating system then host the Docker daemon that hosts a bunch of apps or containers that run on the host operating system. Those containers run natively on Linux, and they share the kernel of the host machine. So it's a shared model. This gets kind of complicated. This is one of those ones where if you're really interested, you can go and read all the background how this works. I used Docker for about 1.5 years before I ever read on how this works. You don't need to know. For the most part, you don't need to care. Docker abstracts most of that away from you, and knowing it doesn't give you any more skills than not knowing it. So if you haven't actually researched that yet, I would advise don't go use it a whole lot. And if you really want to nerd out one night and you can't sleep, then go read it. But Docker runs as a discrete process, and as a result, it's very lightweight and efficient. You can max your machine out very, very easily. When I first put this demo together, I was using a queuing system as well as Mongo, as well as Node, as well as Python. I was running a whole bunch of things for the later demo, and I actually ran out of memory on my machine. So if you are going to set it up, you do need to allocate enough resources to be able to run it to the Docker daemon. Compare that to a virtual machine, and this is VMware or things like that. What you've got is the infrastructure and then a hypervisor, and then the hypervisor runs a full copy of each one of the operating systems. So this could be Windows, that could be Windows, that could be Linux. So basically, the virtual machines run a full-blown guest operating system. They have virtual access to the host resources through the hypervisor. They don't have actual direct access to them. As a result, stuff doesn't work a lot of the time. There's a lot of problems with running them at scale that you wouldn't actually have with something like Docker. And in general, VMs provide an environment with more resources than most applications need. You don't need to run a full-blown version of the operating system in order to take advantage of the underlying hardware and network infrastructure. So advantages of using Docker: fewer resources. You can stick a lot more of them onto host machines. So where you might have been able to get 2, maybe 3 VMs onto a single big Linux host, if you run something like Docker, you can get theoretically 50 to 100 packed onto one machine, depending on how big the machine is, how many resources they have. The Docker containers are great because you can run them anywhere. And you can set up identical environments for dev stage, test, and prod. That's a huge advantage if you're actually trying to get your code from your machine into a dev environment, do integration testing, then get that over to the test environment so the QA people are testing. They're using the same code you are because they're all running Docker containers. When you get it into staging, you're doing blue-green deployments. Once again, it's very, very predictable. I think I've probably rolled back something like about 20 production releases in my life over the course of 20 years because it didn't run in production where it ran in stage, or it didn't run in prod, worked in stage, and it worked in test. So I've had variations of having to roll things back where it didn't work in prod and it worked everywhere else. Since I've switched to Docker, I've never had that happen once. It's faster to spin up. I've seen Kubernetes clusters and ECS clusters able to spin up like 50 containers in seconds. If you're using something like Fargate launch types in AWS, it's slower. I don't like Fargate, but whatever. But in general, Docker containers are much faster to spin up. So if you have a cluster that has to go from 2 servers to 10 servers or 10 servers to 20 servers, you can spin up another 10 in 30 seconds, as opposed to virtual machines that take 3 to 5 minutes each to start up, and then you're trying to install software. And we talked about secure and flexible before. All right, installing Docker. Looks like we have pizza, so I'll just get through this little step, and then we can eat. I'm hungry too, okay. So on Mac OS, use the installers for docker.com. Don't use the brew install, it doesn't work properly. There's a tool called Kitematic for Docker. Most people don't know about it. Everybody should know about it. Everybody should use it. It is full of awesomeness. The other thing is use the Kubernetes engine for Docker. That was all those weird containers you saw running in my images before with K8s in them. The Kubernetes engine for Docker is actually pretty slick, pretty smooth, runs nicely. I'm assuming that most people in the room are probably on Macs. So where'd my little Docker thing go? Apparently I don't have enough screen real estate to pull up the... I'll have to pull this up on the break. I don't even know how to get to the other things that are on the top toolbar.
Switch to the Finder.
To Finder?
Yeah, that'll free up some space.
I'll just come through here.
Let's see, you can see it now.
Oh, okay, there we go. Cool. Yep, so under here we've got, if you come down, when you install Docker, definitely go with more CPUs, 4 gig of RAM. Under Kubernetes, there's this enable Kubernetes option. But the other big thing to do is come down to here, and there's this thing that says Kitematic. So Kitematic is this awesome tool that lets you browse all the containers inside of the Docker Hub collection. You can spool up new containers in seconds, and we'll actually use this later. It actually has all the running containers and shows you all of their logs interactively. One of the biggest hurdles in using containers is actually viewing logs and monitoring and actually handling all of those kind of things. Kitematic makes that super easy for development, and in production when you're running them in places like GKE and AWS, you can use things like CloudWatch to view the logs. But for local development, Kitematic is your lifesaver. So we'll actually demo using this in a second. But that's pretty much all I'd say is make sure to enable Kubernetes, use the default install. Don't try to use the Docker Hub, the brew install, it's terrible. Windows, I don't use Windows. Use the installer. Not biased at all. Linux, there's Docker packages available for apt-get and yum. If you're trying to install Docker on an EC2 instance, don't try to do that. It doesn't work properly. AWS actually have their own version of Docker that runs out of the AWS registry with special AWS commands. Learned this the hard way and struggled with it for 2 days. So if you're going to be using EC2 instances in AWS, use their AWS Linux 2 base AMI and use the Docker agent from the command line. Your life will be happy. Don't do that, life will be sad. You do need to sign up for a Docker Hub account. Important safety tip, your Docker login is not your email address. The number of times I've struggled with, I think I've actually liked the same thing on Stack Overflow probably 400 times because I keep trying to log in with my incorrect thing. So my email address is climberjace@gmail.com. My Docker Hub ID is climberjace. Your Docker login is your climberjace or whatever you come up with it. It's not your email address. And you're all thinking, why am I telling you this? I just saved you a ton of time. All right, let's eat some pizza, and then we'll actually talk about Docker files and how to build those up. I think we're good on time. Yay! 20 minutes. Probably should have a sticker too.
Yeah. Good job, dude.
Yay! Do we get to watch me type later too? Yeah, I didn't do that well. I should have written it while it was on the... How's it going?
This is my normal when pizza gets here at 5:15. Is this how to spell the typematic?
Kitematic. C-I-K-I-T-E.
Oh, kitematic.
Yep. It's for install in the...
Okay. Thanks.
Cool.
How's the project going?
It's all right. Work. And not enough people still. Hasn't changed. Hasn't changed at all. So, getting good at this. How are you doing? What are you working on?
Ultrix.
Cool. Is that going good?
It's going good. It's basically doing a breakdown of a monolith into microservices.
How's that going?
It's going good. We just started last week, so.
Cool. What are you actually doing on it?
I'm the tech PM, so I'm making sure there's a good knowledge transfer and that kind of stuff.
Oh, good. Groovy.
I'm learning. So, yeah.
Cool. I got to make sure I get some pizza.
Yeah, man.
I got to get back up there. Thanks. How's it going?
Good.
Going all right.
Cool.
Just trying to get that runner.
Good luck. I got to get in line for some pizza.
Yeah, get fed. Looks good so far.
Yeah. I actually built like a little microservices thing end to end that I'm gonna demo and write Docker files for interactively. So we'll see how this goes.
Yeah, I wanted to start applauding when you got like song that just spun up just like that.
Yeah, I like 5 times last night, and I practiced it before I started. So.
So I have one very important question.
Yes,
What is the name of your band again?
my band, Velvet Compass.
Velvet Compass. Okay. That's awesome.
I don't think you need the A/B testing.
Sorry?
Good. You don't need the A/B testing. The hat is not racist.
The hat's good? All right. I'm gonna stick with the hat then.
Stuff, you know?
Anything you're excited about?
With
All right. Thanks. Thank you. Probably need to get some pizza. Uh-oh. Left.
Random question about the dock.
Yes.
Never used it. So do I still have to deal, like it's not a hosting service or anything like that at all, so I still have to deal with like AWS or like whoever actually hosting the thing? Or just kind of
Yeah, hosting's a whole... Can you ask that question at the end?
Yes.
Because that's a good question to get everybody to hear the answer to. It was a little bit, but it's a lot harder than you'd think.
I spent 10 hours this weekend deploying a class Elixir. Saved me time.
They probably, because reality is not as pretty as the... Yeah, running in production with containers is hard.
Is it mainly like a performance thing? Like,
Basically, all the solutions that are out there are janky or super expensive. So, I was going to run a second class on ECS, Kubernetes, EKS, Mesosphere, all that kind of stuff later in the year.
what the fuck is Kubernetes?
It's a way of running containers at scale.
So it's like the translator in between the different machines.
If we have time at the end, I'm happy to answer the
sure.
question.
I'll let you eat. Sorry.
No, I'm serious. Like it's a good question, and I think everybody looks at containers and goes, "Yeah." It's not till you try to use them in production that you go, "Ooh."
Gotcha. Fair enough.
It's all yay till you get to prod,
Well,
and then it's all like
life.
boo. Yeah.
That's
So, and it can be yay if you have a DevOps team. If you don't have a DevOps team, you want training wheels. So and guardrails, and you want somebody to dumb it down for you because it's hard. But yeah, running like a 65 node Kubernetes cluster, hard.
Yeah.
So
Nodes.
we
No,
can talk about that. Ready to go?
Do you want to start at 7 o'clock right now? 7:02.
We can get going in a second. Can you take some photos?
Yeah. I did.
Thanks.
I did. You're doing great up there.
Thanks.
I'm gonna eat my
Considering I had to go home sick today.
because of oh dude, I'm sorry.
Yeah, they were thinking
Let's do it. All right, everybody. Cool. Ready, set, go. All right, cool. All right, everybody. Where'd Ricky go? Hi, everybody. Change my name to Dr. Nick. All right. I don't know where Ricky is, so hopefully people are still on the video feed and it's all still working. Cool. Apologies if anyone heard me go to the restroom before. I did take the microphone off as I walked in, just so you know. I almost remembered a little too late. Could have been weird. Anyway, Docker files. Docker files are made up of layers. So a Docker file is what in Docker terms we use to define an image. And the image is the thing that we stamp out lots of copies of them to run them inside of containers. So a Docker file is made up of layers. And Docker files are actually made up of parent Docker files. So a Docker file will reference a Docker file, which will reference a Docker file, which could reference a Docker file. I actually tried to find one last night that went more than 4 levels deep, and I couldn't find one. So I don't know if they actually exist. But each Docker file is made up of a series of layers where the person who wrote the Docker file is bringing in different services from different things. The important things about layers are they're downloaded once, they're cached, and they're reusable. So once you've downloaded a layer for a Docker file, you kind of have it forever. It's kind of cool. Remember before when we did Docker pull on Mongo, and it was like pulling things in? Those were layers, but it was pulling in. So I actually hunted this down last night. Until I did this, I didn't know how this worked under the hood. So a Docker file says from, and then what base image you're going to use. And if you're actually going to do Debbie and Jesse, and you're actually going to write it yourself from scratch, you actually go from scratch. That is the very base Docker image at the very top of the hierarchy in Docker. It runs a service called containerd, which is the thing that basically, it's like the default container instance that everything else runs on, and then the Docker daemon knows how to run those. So the very root image at the bottom of the tree is scratch, and then you add in your operating system, and then you run bash on it, and that's how you end up with a version of Debian. And you give that a tag, you say, I'm going to call this Jesse. So you actually have the Debian Jesse build. Jesse's, I think, version 8 of Debian or something, or 7, or I don't know, I lose track of these things. But Debian Jessie is the one that a vast majority of Python and Node are based on. And then it's actually built like this. This is its actual Docker file. Then we get from Python 3.6 Jessie. So basically, we have another Docker file, which is, the Docker file is called Python, and it's got a tag of 3.6 Jessie. So Python is the Docker file, and then the tag is the version number, including the host operating system. And it says from Jessie, so this Docker file includes that Docker file. And then install Python from source. Now, in my little notes down the bottom here, I actually put a link into...
Hey, Mr. Jason?
Yes.
Can I get you to reshare the screen?
Really?
All we can see is your face and
That's...
your hat.
I don't see the problem. So, if you can see the hat, we're good.
I can see the name tag too.
Okay.
Would somebody who is younger help Jason, please?
You do report to me as of like yesterday.
Poor Ted.
Let's try that again. Is that better? Cool. Love you too.
Please don't fire me.
I can't if I tried. You're awesome. All right, let's see if I can get this puppy into another window, because apparently control clicking is not working in this window. All right, so this is the actual Python Docker file. It's kind of crazy pants. A lot of different things to install to basically run Python. So this is what builds Python on top of that Jessie image. So if you actually nose through these things, you'll actually realize when people talk about security, the number of things you have to install on these things is crazy. It was like last night when I was like building the little Vue app that I used today for this demo. All I did was like create Vue, I'll use the Vue CLI. I installed like 2 packages like Axios and something else, and I had 1,183 dependencies. Docker files are kind of like that, so actually securing them is actually a big deal, and getting them secure is like a thing. All right, so we've got the base Jessie image, and then I'm going to create my own Python 3.6 based image for my app. So my app is going to use this Docker file. I'm going to create a working directory, and we're going to go through all this stuff and how it really works. We're going to copy my code in, I'm going to run my stuff. Yay. All right, cool. So the Docker pull command can pull an existing image from Docker Hub. So I can go Docker pull Python 3.6 Jessie and pull this from Docker Hub, and I will get this Docker file pre-built as an image, and it will run in my container when I go Docker run. Or I can go Docker build, and I can build my own custom Docker file. So I can go Docker build my app, and then it's going to pull down Python 3.6 Jessie. That Jessie is going to pull down Scratch, and that's how that layering thing works. So when we were actually installing Mongo before, when I did Docker pull Mongo, you actually saw it downloading all of these various layers in the background, and all the layers get downloaded. So that's what's going on when you're actually doing that. The interesting thing was just realizing the vast majority of Docker images are only about 3 Docker files deep. I couldn't find anything greater than 4 when I looked. So base images, the 2 that I always use, so when you actually install Docker, you can choose what flavor of Linux you want to use as the base image. So I can use the ones that I find myself using all the time. I do a lot of Python stuff lately, so I tend to actually do a lot of Debian-based images. And I do a lot of IoT work, and Raspberry Pis and all those kind of Linux things tend to run Debian variants. So Debian is a 188 megabyte image as a base image. Something like Ubuntu, also 188 megabytes. The one that everybody tends to use these days, or wants to try to use, is one called the Alpine Linux, which is a 5 megabyte version of a full Linux operating system. And in the demo that we're going to have today, we're going to use a Python image, which is based on Debian, and we're going to use a Node version that's based on the Alpine Linux. Where possible, you want to use the smallest Linux you possibly can, largely because it just saves resources and it's faster to start up because there's very little to download. Keep in mind, a lot of this stuff is cached, so you only take the hit once on downloading this stuff on each server. But if you're going to run 1,000 EC2 instances in a fleet and you have to download a 188 megabyte file, or you want to spin up a new environment, they all have to download it. So you want to go with the smaller one if you can. But as we learned the hard way, the Alpine variant of Linux doesn't have some of the C compilers and other things on it. So if you try to start with the Alpine base image, you may end up fighting the fact that you can't really run C or Java or things like that on here. Whereas out of the box, this thing can run Python, Java, pretty much everything comes on in the box. Not much of a box, tiniest box. BusyBox used to be the most popular image for Docker base images, and it's been surpassed by Alpine now. So these are in order of popularity, by the way, according to Docker's downloads page. So every time a layer gets used, Docker Hub will actually record that a pull happened on that image to pull in that layer. And so far, Alpine's winning in this order. Ubuntu, super stable, CentOS is basically, these two are variations of Red Hat. So if you're running anything in the Red Hat space, that's why you have them. So something to be aware of is the base images. I've had really good luck with Debian. I've had really good luck with Alpine. But Alpine sometimes can let you down, and it can suck hard when it does. So just be aware of that one. All right. So if I want to create a Docker file for an API, I'm going to do it today for a Python API, but it could have been a Node.js API. It doesn't matter. The steps to follow are, we're going to start from an official base image. I would not recommend trying to build your own. Tried it. Doesn't go well. Copy the dependencies file to the container, so that with NPM would be something like your package.json, or in Node it's your requirement. In Python it's requirements.txt. Pick your language. They all have some kind of dependencies file. Then you're going to run pip or npm install or whatever you need to run your dependencies. And what that's going to do is install all your dependencies on the host operating system. Then you're going to create a working directory. You cannot create a working directory. Your life won't be happy if you ever have to debug the thing. So create a working directory, because then you know exactly where to look when things go wrong, and things will go wrong. Copy your source code into your working directory. Set up any environment variables you need. Use a command to start your application, and you get this magic kind of thing that you see on the right-hand side. Who here knows how to code in Python? Who here uses Flask? Should be way more people using Flask. Flask and Express are probably the two fastest ways to get APIs up and running. Happy's pretty cool too, but yeah. Python, I just really picked it up in the last year and a half. Python is now my favorite language ever. I don't know why I shunned it for so long, and I should not have. So basically what this is going to do is we're going to pull in from Python version, we're going to copy our dependencies file in, we're going to run a pip install, which basically is the same as npm install dependencies. We're going to basically set up a working directory, copy our source code in, going to set up any environment variables we need, and then we're going to run it. I'm going to actually do that in a second. So I'm going to show you how to set up a Docker file. So Docker file tips. When you are writing one of these Docker files, run only one process per container. And that isn't necessarily required, but your life will be hell in production if you don't do that. I'm going to talk about this a lot, and I'm going to beat this horse to death. Run only one application per container. So in your container, you are going to run your app. If your app has two different services, run them in two different containers. Each container should have one executable running. The reason is, if it dies, you just restart the container. If you need to log the logs from it, you just spool the logs from the container out to CloudWatch or whatever you need in production. And if it dies, you'll have all the logs for that container instance, so you can see why it died. If you start mixing multiple processes in there, containers won't automatically restart themselves when they die and terminate. I'm going to talk a lot about that one.
That's a production comment or?
Everywhere. Run one process per container everywhere. It's really best practice, because if you do it in dev, you'll end up trying to do it in prod, and when you try to debug it, your life won't be happy. So production debugging and monitoring of Docker containers goes really well if you have one process per container. Once you start running multiple processes per container, it gets really hard to figure out what happened where and when from your logs and your events, and then containers don't get automatically restarted. Yep?
So is this dependent if the language is like single-threaded versus multi-threaded, or is this rule of thumb?
Depends. Actually, going to cover that in a second. So yes, there's some subtlety there. There's port mapping consideration. So by default, nothing can talk to what's inside of a container, and containers can't. They can call out to things, but nothing can call into them by default. So you have to be very careful about how you map ports and what ports you make available, and you have to plan that in advance. You want to plan for auto-scaling. So you want to plan for containers dying all the time, either because of a bug, but also because we decide that we've got some load that we have to handle for a couple of hours, and I need 100 instances of my container, and then that load goes away, so I want to spin back to like 10 instances of that container. So your containers need to be able to handle getting auto-scaled up and down and have graceful termination. And all of that has to be done in a way that's completely stateless, so that you can scale up, down magically with your containers, add them, remove them. You've got to actually think a little differently. You've got to plan your service not to necessarily last forever, but you have to plan your service that it could get killed off at any time. So some other tips: yes, use event loop and thread managers so you can run multi-threaded applications that way. But what you want to avoid is process managers like PM2. So if you were to run PM2 on a Docker container to run multiple instances of Node on a container, getting those logs out of PM2 into something like CloudWatch or Elasticsearch suddenly gets a lot harder. Monitoring gets a lot harder. If PM2 is actually recycling a lot of things and the container's getting unhealthy, most container management systems aren't smart enough to restart something like PM2. So if you run just one instance of something like Node, you run that inside of your container, and then you just run multiple containers, because you can just simply go, container scale 10, you get 10 of them. It's the same thing that PM2 does. So essentially, Docker files give you what a process manager like PM2 would give you for multiple processes. So you really want to be running just a single process per container, and your life will be happy. If you do it a different way, it's just going to be really hard to debug in production, especially when you've got a distributed system with multiple containers all going off asynchronously. Life is not going to be happy. So there's my tips. Feel free to ignore me. But all right, so microservices. This is the kind of stuff we're all starting to build these days. So I've got a bunch of devices coming into some kind of a load balancer thingy. Could be Nginx, could be an ALB, an ELB, an NLB, a yada, yada, yada LB. That comes into some kind of a gateway thingy. And then we put a queue in there because, well, if we get inundated with requests, we don't want to drop any. And then we might then start farming things out to lots of different microservices. So we might have a microservice dedicated to just search that talks to Elasticsearch. We have a thing that'll do just invoices that talks to our Oracle database that's keeping all of our financial records in it. Orders and customers might be in MongoDB. Users, we might throw in DynamoDB because we're lazy and we hate ourselves. But not a fan, in case you couldn't tell. Some of these things are easy to run in containers. Like I can run MongoDB in a container in one line of code, as you saw before. Super simple. Running a clustered, high availability, multi-node cluster version of MongoDB in multiple availability zones, way harder to do with containers. And that's where things like hosted services will make your life easier. Something like DocumentDB, which we just discovered last week, yay, has saved us having to build our own MongoDB cluster, which is painful. So you can get all of these services available in Docker containers. And for development purposes, when you're running one instance of these things, life is simple. When you want to run a cluster, not so simple, a lot harder. Largely because things that actually maintain state, such as databases, are actually a lot harder to run in container orchestration systems than things like microservices that do not need to maintain state. So there's a phrase you'll see later on: you need to treat containers like cattle, not like pets. If it needs care and feeding, it's a pet. If you love it and it can't go away, it's a pet. So these things are pets, largely because they maintain state. Now the nice thing about these kind of patterns is if you start getting hammered on search, you can just simply scale up your microservices from search and you're fine. You can scale them down and then save yourself the money. And then you can start running these containers in all sorts of different creative ways in production. So there's a good book that I recommend for everybody who's trying to get into this stuff. I've got a reference at the end. It's a Python, React, microservices framework book, whatever. I'll leave the slide up at the end. You should all go off and buy it. It's from a guy called Michael Herman. Some of you guys who've been to Galvanize have been trained by him, so you will know him already. It's an awesome book, very well written. This graphic is from his book, and this gives you an example of how microservices all kind of interconnect with one another. Now the trick with this is you're going to be running multiple instances of these things. So I'm going to be running multiple instances of different services, but some of the things like databases are actually hard to run multiple instances of because they maintain state. And that's where something like volumes will actually come in handy. All right, any questions before we get to the next little bit? Cool, all right. So, services, networking, and ports. So Docker networking. Docker actually comes with a rich networking inside of containers, and it actually has a built-in router, and it has a built-in little DNS server inside of it that can resolve internal addresses inside of the Docker daemon. Graphics taken from the Docker docs. So basically, there's an external Ethernet port, and this is where your service communicates to the outside world, comes into a router. That router actually talks to the Docker daemon. It actually has its own virtual interface that actually then provides each container with its own virtual IP address. So containers have their own IP addresses, and those containers can be given names, and they can do DNS lookups. And that's about where Docker ends, and that's where Docker networking starts to suck. And that's when, so this is about as advanced as Docker networking gets. So I can have, once again, a host, and I can have an Ethernet port on the outside. So that's how you communicate to the thing. Comes into a router. I can set up 2 separate networks, and then I can set up virtual interfaces, and each one of these will get their own different IP address CIDR ranges. Now, this gets really tricky because in Docker, unless you use some kind of container orchestration system, you actually can't have multiple services sharing the same port. And it doesn't include things like service discovery and all the other fun things that you need to run a service at scale in production. So if I wanted to take normal Docker and run 10 containers of the exact same service, Docker out of the box can't do that. Kubernetes can, Docker Swarm can, Amazon ECS can, managed Kubernetes services like EKS, GKE can. But Docker out of the box can't, and you can mess around with it and try to force it to do it if you have the Kubernetes engine installed, but you're going to hate your life. Once again, you need to start looking at Kubernetes. For development purposes, which is what you do 99% of the time, unless you're a DevOps engineer. If you are, I don't know why you're in this class, because you already know all this stuff. 99% of your development time, you're going to run one instance of everything. So port mapping. Ports must be explicitly mapped. So basically, when we want to expose ports to the outside world, we're going to use port mapping. So if I have a host, I'm going to run the Docker daemon inside the host. I'm going to have a couple of containers. I'm going to have a Node app, and I'm going to have a Flask app. And I want my browser to be able to talk to both of those. I'm basically going to say I want my Node app to be available on port 80, even though Node is actually exposing the application on port 8080. And my Flask app is going to expose its API on port 5000. And I'm actually going to make that available to the browser on port 5000. So what you end up doing is putting a little ports block in your Docker Compose file that we're going to talk about in a minute that actually maps the ports just like that. You'll see there's a thing in there called expose. And expose is where you want to provide, I actually have this wrong, so let's screw this up. Expose is where you want one container to expose its port to another container. You can use, it used to run differently, but basically you use the ports command to expose things to the outside world. Expose is used internally. So Docker compose file, a bit more talking, then we're going to do some typing. So the Docker compose file defines a set of containers that are designed to work together as a group. That's that microservices kind of picture. And how they actually communicate with one another. So we have a Docker compose YAML file. We're going to give service names to the containers. So that's that whole DNS idea. We can actually give a name to the containers. We can link them together, so we can make container A talk to container B, and container B can talk to container C. We set up the port mapping. We can define our networks. We can map volumes. This is actually important if you're going to be running MongoDB. I don't actually have any slides explaining this. Probably should have. So if I'm going to run something like MongoDB and I'm going to be bringing containers up and down, every time I bring the container down, I lose my data. So what you can do is map the MongoDB's data DB folder, which contains the data. You can map that to actually store its data on your local hard drive, so that when the Docker container goes away, the data's still there. Turns out you can do that in production too. So you can run Docker on an EC2 instance and actually store the data back on the hard drive and store it on an EBS volume. And that way, when your container goes away, your data's still on the EBS volume. So if your container dies, you don't lose the data. So if you've got a service where you can have like 3 instances of different nodes that talk to the same file system and share that, and that's actually how they're replicating the data with a shared log or a shared data file, you can set that up using mapped volumes. And then you can select your Docker images. So you could actually either pull a pre-built image from Docker Hub, or I could actually build my own from a Docker file. So the nice thing about the service names and the Docker compose file is that I can run the Docker daemon inside my host, and then I can say, all right, then we're actually going to build this. I can build a little front-end app, and I might run multiple instances of it, but it's going to be basically Node.js hosting a Vue.js application. I'm going to run my backend using a Python Flask app, build a little API with that. And basically, the front end depends on the back end, but it doesn't have to talk to it. So in other words, the front end should not start up until the back end has already started, because the front end basically won't have anything to talk to. So you want to get the order in which the service is launched correct. But the front end and the back end inside of the Docker daemon don't need to talk to each other, because your browser is going to talk to the front end. It's going to pull back the Vue app, and the Vue app's going to make a request out to the Flask app on its API. So the Flask app, though, does need to talk to the Mongo database, so it actually links to the Mongo database so they can talk to each other. And then I've got this little simulator that's going to go and create some sample data every 5 seconds. And that simulator is going to write the data into MongoDB. So my browser now needs to access the front end and the back end. And I need to map the ports to make that happen. So everyone following what we're going to do? All right, training wheels off. I have my cheat sheet in case I screw up, because the demo gods never smile on someone this well. All right, so what I basically have here is a little project that I put together last night. I've got my simulator, my front end, and my back end. Notice I don't have Mongo. So for my back end, I've got like a little Python app. So I'm basically building a little Flask app. I'm pulling in some environment variables for like where's MongoDB located. And then I'm basically exposing a Hello World API. And then I've got a readings API that's basically going to pull a bunch of sensor readings out of the Mongo database. I've got a simulator that's also a little Python app, and it's just writing readings to the database. So I'm basically creating a sensor reading object every 5 seconds. I'm picking a random number between 1 and 100, and I'm just shoveling that into MongoDB every 5 seconds. 30 37 lines of Python code. And I've got like a little object here that I'm using as a serializer to write to MongoDB. So that guy is going to write things in every 5 seconds. I've already got a Docker file in for that one. And then I've got a front end, which is a Vue.js app created just with the Vue CLI, just default build. Set it up to basically call the API and make those requests. So going back to the slide. Where is that guy? Hangouts. What's it trying to do? Oh, I don't know what that is. Let's go back to this guy. So we're basically going to build all the links for that. And I'm going to build the Docker file for this guy. All right, so let's just look at the back end briefly. So the back end, once again, it's like 50 lines of Python code. So the back end, got a few little imports. So those imports are in my requirements file. These are all my dependencies that need to be installed. All right, and then I've got my app. So I'm basically building an app, going to cause the thing and just say, yeah, everyone can get in, don't care. Who needs security? I'm going to connect to MongoDB. I'm going to expose my route. I'm going to expose my readings. I've got a little serializer object. I've got a little API serializer object. That's about it. The thing to run it. Yay. All right, so first thing I've got to do is I've got to create a Docker file for this thing. So I just create a Docker file. Typing while everybody watches me. Cool. All right, so first thing is from, and then I'm basically going Python, and I want Python 3.7.2, which is what I was testing with last night. So that's my sort of base image. That's the thing that I'm going to pull in. The next part is I'm going to copy, and I'm going to copy my requirements, requirements.txt file to the root. The next thing I'm going to do is run pip3 install -r requirements.txt. That's the same as npm install package from package.json. It's the exact same thing. All right, the next thing was, you remember I had some environment variables that I needed to set. So I'm going to set Mongo host. It's going to be Mongo because I'm going to call my service that. My environment variable is going to be, oops, there we go, it's my caps lock. Mongo. Typing while people watch is hard. Standard Mongo port, and then you have to give it environment, so Mongo. Why is that thing still there? I know why it's there, I'm just going to have to put up with it. So Mongo, what do they call it? DB. Looked at my cheat sheet, sorry guys. All right, there's a couple of environment variables required for Flask apps. Yay. And I'm going to run it in a debugger so we can actually look at the debug logs. Oops, debug 1. All right, cool. So now I'm going to build my working directory. So workdir, source, yay. Now I'm going to copy my source code from the root directory to source. Cool, all happy. Actually, no, my working directory at this point will be the source directory. So, and then the last thing is I need to start up my thing. So I'm going to run a command. Now notice before I did a run up here, run will run a thing and then return back to the installation. The command will run a thing, and if it exits, it will exit the process and completely bug out of the container. So for example, if my process was to quit while running a command, game over, the container will terminate, and it will notify Docker, and there's events that go off, and you can detect that, and then automatically spool up another one. All right?
Run is just background.
Run, yeah, it's kind of. It's the difference between like npm build and npm run. So, or yarn serve and versus yarn add. So it's sort of the equivalent thing. So I'm going to run my little Flask app. So it says Flask. Good Lord, this is, where are we? Flask, run, and then a little bit of craziness that Terry knows really, really well by now. Running the host command, and that's pretty much it. Oop, need a space. So these Docker files are very fussy about formatting. There's a linter clearly that I have turned on to make me not screw this up. Latest version of Visual Studio that installed this week sadly has this really weird auto documentation thing that I've turned off 3 times now. It keeps turning itself back on again. You can add comments into here. So yay. All right, so an interesting thing about Docker files is they run from top to bottom, and they are cached from top to bottom. So each one of these different commands, if you run it, the next time you run a build on that Docker file, if you haven't changed that step, it won't rerun that step. It'll actually go back to the cached image. Remember we talked about layers before? It does the same thing during builds. And there's this process called multi-stage builds, which we're not going to demonstrate today, where you can like build a base image and then have other things share that base image. And you can do that interactively within the one Docker file. So one Docker file will build an image and then use that temporary image to build another Docker file on top of it. You can do some really cool stuff that way. But basically, things like environment variables kind of never change. My requirements file might change. So what I might want to do is put my environment variables at the top, because every time I run this, the Python base image isn't going to change. My environment variables aren't going to change. I may change my requirements txt file. So if I add a new line to that requirements txt file, the next time I run it, it's going to run everything from that point forwards again and build it. Now this isn't a big deal when you're building one Docker image. When you're building 27 of them in a project, it can take a long time to build. And so getting the order in which you run things in a Docker file correct is kind of important for your sanity, unless you like sitting there watching your computer for long periods of time, which I kind of like coffee. It's nice to sit there and watch it. It's cool. You know I like coffee. Best barista in town, I think. No longer a barista. All right. So that's my Docker file, and what I could do is now navigate into the backend folder, and I could actually go Docker build and build that from there. I'm not going to do that, but I could, and that would build that Docker file, and then I could run it, and I could build that image. But what I'm going to do now, to go back to what we talked about before, was I'm going to go back, and I'm now going to set up all of the links between these different services to make sure that I actually have everything set up correctly. So I'm going to create a Docker compose file that actually has all these different links in it. All right, so now I'm going to come down and basically add docker compose.yaml. You'll notice Visual Studio knows all about these kind of files. So first thing is you need a version of the file. Then I'm going to define my services. And then each service is indented. And you'll see that Visual Studio Code, who uses VS Code? Who doesn't? Okay. Sorry? I love it. I switched to this and I'm a huge fan. All right, so I'm going to I need to run Mongo. So I'm going to use the latest image of Mongo, and I need to map the ports so that it's available, because I want to basically make it available to other containers, and I want to make it available through the Robo3T. 27017. I don't know why they had to pick such a hard port to type. All right, so the next thing I'm going to do is run my next one, so my simulator. And now the simulator actually has a Docker file. So if I come down to see in here I have a Docker file. So I'm going to basically build my Docker file, and then I'm going to say context, simulator. So that's what folder I want to call in my little folder structure. So that's the child folder. Context has a T. Yay. And then I have Docker file. Kind of redundant, but sure. Then I have environment. So I'm going to I set up my environment variables, and I'm going to say Mongo host equals Mongo. Yay. So the Docker compose environment variables will override the ones that are in the Docker file. All right, so next one is I want to run the back end. So let's go, back end. And once again, you know what? save time. So this is going to be back end. Same deal again, except I think I'm going to leave. The other thing I would need is, like, I can put my Flask environment variables in there, so I can say Flask env equals dev. That'll actually cause more debugging to happen. I can go Flask debug equals true in here, or 1, or whatever I want to put in there. So I could actually set environment variables through here that will override what's in the Docker file. Now the interesting thing here is I've actually got to link this into Mongo, because essentially the backend has to talk to Mongo. Cool. Depends on, and I always type this wrong, which is why I have a cheat sheet next to me, because I always put a dash in here and it's a underscore. It depends on the simulator. And then the last thing is ports, because I want to expose this to the outside world. So I'm going to say port 5000 maps to port 5000. Alrighty, so what I've basically got now is a backend that's going to build my Docker file. The Docker file for my backend is going to pull in Python. It's going to set these environment variables, but they'll be overridden by my Docker compose file. It's going to install any requirements, set the working directory, copy my code in, and run the thing. Back over here, I'm going to make that available to the Mongo container. So you have to have this link section in there to actually link them up together. But I don't want to start the API until the simulator's running, because until I have some data, doesn't make a whole lot of difference. So I want to make sure the simulator's running first. Then I'm going to expose the ports. All right, last part, front end, my last service. Yay. All right, and once again, it's going to come up here and copy and paste. There we go. Front, end, front, end. That should be simulators. Simulator, singular. No, hang on, that's right, that's back end. Simulator, back end, front end. Yep, cool. Environment. And this guy depends on the back end. But it does need a link to it. Because if you come back to, oh good Lord. I do not like Google products, except for slides. If you come back to here, it's going to download the View app, run it in the client, and then it's going to make a request on port 5000. All right. So from here, I'm actually going to go back to this nice big thing. So I've got my Docker compose file in here. So now what I'm going to type is Docker compose up and then build, and that'll build all my containers. And I'll probably have a typing bug. Build. What did I do wrong? Oh, sorry. Yep. That'll learn me for cutting and pasting. Don't cut and paste, people. It's bad. It's terrible. Good Lord, I suck at this. Okay. Cool. So now it's going to start building everything. It's going to run it. Yay. See, it's installing the requirements, installing my dependencies, downloading them all from Python, same as npm. Yes, it does take this long. No, this is not a slow Mac. You get to enjoy coffee. So for the View app, it's a View app hosted in Node.js, and Node.js is being used to actually host the Vue.js app, and then that's been run in the Node.js container. So while we're waiting for this, so you'll see it's actually creating it, it's running it, all the services are running. It'll actually tell you what port it's running on. You can run this as a daemon, but I find the first time I do this, I kind of like to read the logs. But remember I told you about Kitematic earlier on. If you come over to this magic Kitematic here and hit Control-R, yay, shows you all your running containers, along with all of their logs. So I can go to the simulator, and I can actually read its logs. I can come to MongoDB, I can read its logs. I can go to the front end, and I can read its logs. And I can go to the back end, and I can read its logs. So that's kind of cool. You can hit this exec thing and then interact with it with a bash script for sure. You can do that from the Docker command as well. So you can go docker exec and actually, it's the equivalent of SSHing into the instance. So yes, you can do it through here as well and just exec, and that'll work too. So yeah, this is kind of cool. It writes some data off to the database. Yay, it'll show you your logs, and we're all a happy camper. So I'm just waiting for more values to write, whatever. But then I can come down here and I've got my hosts available, and to remove doubt, I put them on shortcuts last night in my browser. So I can come down here and I can go to my little Hello World API. There's my API. So 127.0.0.1.5000. Cool. Now I can come down to my API and it'll show me all of my readings. Now I can go to the front end. Ah, damn it. So don't know why that's not working. Ah, I did not actually map my ports on the front end. So there you go. All right, so you can actually stop it by hitting Control-C. That'll stop the services. It can if you run it as a daemon. If you run it interactively, you have to kind of cancel it. It won't, once you run it interactively, you're in a, it doesn't work. So Docker Compose up build, except I'm going to run it as a daemon now. Oops. Yeah, that's it. So that'll just rebuild only the front end. All the rest of them, it just cached everything. So now it's going to rebuild the front end, redeploy the front end, and the front end will actually have the port mapping in there. I'd say last night when I was actually trying to build all this stuff, it took me about 3 hours to build the whole demo end to end. Probably an hour and a half of it was just debugging ports and messing around with things. It's a pain in the butt. Once you get it working, it kind of works pretty well. There you go. There's my readings. Yep. All right. Yes, quick question.
So say you're in your front-end app and you run like npm like auditfix or like npm run build or something. Does Docker know that some of those dependencies have been changed?
Yes. Yep. It actually looks at the files and figures out what's changed, does change detection on it. If you add requirements into the package JSON file, it'll redeploy them. It's pretty cool. All right. We got time to finish up? Yeah. 5 minutes? Cool. All right. Groovy. Look at this. All right, why Docker Compose? I can do microservices. Try doing that without microservices. It's kind of crazy. Developer enablement. I can take what I just did, check it into GitHub, give it to him. He can load it up on his machine, go Docker Compose up build, and if he's lucky, which he usually isn't, it'll work. I love you, man. So it actually means that if you onboard a new team member, your new team member just downloads the source code, goes Docker Compose up build, boom, they have a working environment. When you have 27 databases, 5 queues, or 27 Docker microservices, 5 queues, 3 different databases, and you have all these dependencies, try setting that up by hand. Super easy if you've got like a basic Node app with a Vue front end, yay. But once you actually get into like making a full production app and you're actually starting to scale things out. The other thing is it actually, so check it in into a single master, new devs up and running easy, up and running in minutes. Environment consistency, so I can run this on my machine, his machine, I can run it on a Windows machine, works the same everywhere. Can run in production. We even did this on a recent project. We got kind of desperate to launch everything really quickly, so we just ran Docker on an EC2 instance, went Docker Compose up and ran it there, and that worked. Ran the whole stack on one EC2 instance. It's not ideal, but it worked. It's easy to interpret for CI/CD teams. So if your team that's actually, I say that with Terry sitting in the back struggling with something right now, but if you're trying to figure out how to get a CI/CD pipeline to work correctly, Docker Compose gives you a blueprint of how the services are meant to work together. Because you can follow all the port mappings, you can see the logic of what's supposed to talk to what. So it actually gives you a roadmap of a working system. All right, the hairy bits at the end. And clearly I don't like hair, so. container first principle, containers are like cattle, not pets. So that was said to me again in a meeting this morning, even though it was in my slide deck. You've got to treat containers as if they're going to... Any vegans in the room? Yes, no? One? You're okay with it? All right, yeah. So basically, you don't kill off your pets. So things like databases, things like queues, things that have state are pets. We care for them, we feed them, we make sure they stay alive at all times. Containers, we kill them off whenever we feel like it, whenever we're hungry. So basically, this is a phrase you'll see everywhere in the container orchestration space. Containers are like cattle, not pets. Keep that in mind. You need to build your containers in a way that they can die at an instant, because when you have auto scaling set up, they're going to be started up, shut down all the time, and you need to design your software like that. So running Docker in production, there's an easy way that sucks that you don't want to do, but it works and it's easy, which is you install the Docker daemon on a Linux host, like an AWS Linux host. You upload your Docker images to that EC2 host, and you run it. So it's basically something like this. My AWS instance, there's my Docker containers, and I run it. Yay. You'll find that won't work, and it sucks, and it's not good practice, and it's not very secure. So you'll find that when you want to run containers in production, you're going to start looking at container orchestration. And clearly, we're not going to have time to cover this today. There are a lot of options out there. They are all hard. Some suck more than others. And the ones that are easy are useless. The ones that are hard are good, but they take a team of people to run them. So it's like, or they cost a lot of money. So super expensive, but easy. Free, easy. Once you get it installed, which took me about 17 hours to get a properly debugged service up and running on one cluster of hosts in AWS. And the other thing is experimenting with it. You can't run it on your laptop. You can, it just doesn't really work. And I think my bill for experimenting with that for a month on AWS was like $450. So there's no easy way and cheap way to run it, just to experiment with it, to actually learn how to do it. Same with running your own Kubernetes clusters. You can mess around with things like Minikube on your laptop, but yeah. Yep.
Is there a certain level of EC2 container that you need to support that? Is that where you get the cost from?
Yes, sort of. So if you're going to run like a Rancher host on the cheapest thing that Rancher will run on, I ran it for a month, and I ran that, and I ran DocumentDB as well for a month, and that my bill was like $880 for a month. I gotta submit my expense reports, reminds me. Yeah, it's not cheap to experiment with this stuff, and you can't run this shit on a T2 micro. It just doesn't run. Sorry?
Like a medium instance minimum or something like that?
Yeah, I ran like 5 mediums, and you have to have a management node that has to be a large. There's no cheap way to do this. So things like Amazon ECS and Amazon EKS, and there's the Kubernetes container engine for the Google Kubernetes engine that will run your containers for you, are kind of a lifesaver. They're very fiddly. They're hard to learn how to use. There's lots of steps. They're hard to automate, but they make running containers pretty simple. But I talked about, if people are interested, I can run a class on container orchestration whenever the next available spot is. But yeah.
So just to make sure I understand correctly, so using containers in production, you have to use one of these orchestration tools, which is a pretty...
You don't have to. You can do it like this, but that's ridiculously easily hackable. And also, it doesn't manage them for you. If the containers die, you have to manage them. Whereas here, like AWS ECS, honestly, this is the easiest one out of all of them. So you upload your containers to ECR, Elastic Container Registry, and then you run them in ECS. That is by far and away the easiest thing, but it comes with tons of limitations and things it can't do. Kubernetes is like, owns 70% of the container orchestration market. That runs Kubernetes. That's actually died. Docker has given up on it, and now they actually are switching over to Kubernetes. That runs Kubernetes. So it runs its own thing, but it also runs Kubernetes. Kubernetes is hard. So I got this great graphic. Learning curves for different container orchestration engines. I'm glad I got to use this. My level of tolerance for pain on crazy hard things to install is insanely high. My crazy tolerance is through the roof. Sig knows this. I got something working, but it took me like a week of messing around for like 4 hours a night just for fun, because I'm weird. And I got it working, but then it occurred to me, like, trying to maintain this as a human being is really hard because you actually have to care and feed for it. So this graphic is not actually unlike the truth. Everybody thinks Kubernetes is easy until you actually have to do it. At my last company, we were trying to roll out Kubernetes, and 7 months later, we didn't have a single container in production with a skilled DevOps engineer running the show. It's just really hard that you don't want to give your entire production workload and your company's ability to make money over to a Kubernetes cluster. It's pretty hard to get it running. So things like ECS, ECR, EKS, GKE, acronym, whatever. You want to do that unless you absolutely don't. You absolutely can't. To be running Kubernetes, I actually read somewhere that if you're going to run less than 50 containers, use ECS. If you're going to run between 50 and, say, 3,000 containers, think of something like Docker Swarm or Rancher. If you're going to be running more than 3,000 containers, then look at running your own Kubernetes cluster. That was a metric that I've actually heard. So, you know, places like, I think, is it Netflix or Google said they run something like 1 billion containers a month through their cluster. And they just start up and shut down all the time throughout the day. They actually restart the containers every hour or every 2 hours. They're just coming in and out. They're all cattle. They just come through the slaughterhouse. But Kubernetes is hard. Yeah. Kubernetes is hard. If you think it's easy for about the first 2 hours, and then your just life goes down this big sinkhole. So, just to finish up, some classes or courses or follow-up things that I totally recommend in every way imaginable. Michael Herman's class or course, microservices with Docker Flask and React. I loved this. He actually does it all with TDD. That's the part I don't love, but whatever. But he has this amazing course that teaches you how to build Flask apps, build Python apps, containerize them, deal with database upgrades in containers, mounting volumes, dealing with Docker Compose, launching them in Amazon, launching them on EKS. He does the whole thing end to end and shows you how to build it. It's like $20, best $20 you'll spend, better than almost every Udemy course on the planet. This Kubernetes microservices course is fantastic at explaining how Kubernetes works and also microservices in exquisite detail. The guy's got a British accent, so he's even cooler. But this is totally worth your time as well. I highly recommend that class as well. If you like videos, do the Kubernetes one. If you like reading stuff, do the microservices one. Do both. They're both cool. And that's it. This is what I'd recommend as next steps. Thank you, everybody. How are we doing time? Cool. Questions? I'm sure there's going to be 1 or 7. Yep.
I'm wondering if you have an experience converting Docker images to Lambda.
Nope. Nope. Yet to actually do Lambda in production anywhere for anything ever. Just haven't done it. Know how to do it, just don't do it. Yep.
When you're opening, you said that you used to restart machines and blow stuff up for 20 times a year. Now you only have these.
It wasn't 20 times a year, but yeah.
What was the one time you blew it up here?
Oh, with containers. So with virtual machines, when we were starting up virtual machines and we had different environments, there'd always be some like OS problem that would prevent something working in prod that worked in test because there were slight differences. Especially we were running Windows hosts and .NET applications. And some of them would auto-update. Well, it's Microsoft. Some of them would auto-update. So we turned auto-update off everything, or so we thought. And every now and again, one of our servers would be on a different version and things wouldn't work. With Docker, you don't have that problem. It just runs the same thing everywhere. It always runs the same way. So that isolates you from any changes in the underlying operating system. So for Linux hosts, if I have to go patch my EC2 instances that are actually hosting my application and apply security updates, my containers will run the same way after those updates. So I can apply security patches with reckless abandon and not worry that my code will run differently because it runs the same everywhere.
So the one time you had to roll back, what was it?
Rolling back in the...
You said you had to blow it up and redo it.
Oh, yeah, we just had problems with like different versions of Windows, different versions of Linux. Our code just wouldn't work. And so we had TeamCity set up to deploy to all the servers. And then we just have to, we use the rollback button all the time because we'd deploy stuff and be like, I don't know, sad face, didn't work. Because the Windows host was actually was different. And because of that, the application didn't run. There's like a different version of ASP.NET running. That happened to us all the time, like 20 times over 4 or 5 years. We'd deploy things and have to roll back, then we'd be patching the OS, then we could try again, and became this like iterative, like try things out to see if they work. Ever since I've switched to Docker, I've never done that. It runs the same everywhere.
You could change anything. What else? Would you change anything? Anything you would on your wish list?
In the Docker flow?
Yeah.
I would make Docker able to handle multiple instances and get rid of Kubernetes as a requirement, which you can actually, it kind of does. So that little thing that was, where was it? This little puppy up here. If you run Docker with Kubernetes, you actually get a Kubernetes engine under the hood running your Docker, and then you can start to run multiple instances of things, and it actually uses Kubernetes networking, which there's a great class on Kubernetes networking run by the Rancher folks. So the Rancher guys ran this thing. It was awesome. I never really understood how container networking worked at a really low level till I watched this class. So the Rancher folks, if you're interested in container networking, look up Kubernetes networking Rancher 2.0, and there's a hour-long talk from the Rancher folks explaining how it works under the hood. Basically, Docker's networking is pretty terrible and pretty limited. Like, it kind of works, but it's not really good for production. So what I can't do is spin up 10 containers on port 5000 and then put a service in front of them. You can do that in Kubernetes with like 3 lines of code. You can't do that in Docker at all. You have to put them on all different ports and then port map them back to the same, like put an Nginx in front of them and port map. It's miserable. You don't want to do it. So ECS recently got the ability to do that. So you can have 100 containers all on port 5000 now, and you can give them a service in Route 53. But they only got that because they did it for Kubernetes. So it's a Kubernetes feature they retrofitted onto ECS that Docker doesn't have natively. So basically, networking in Docker is limiting. It's great for development, but when you want to run multiple instances of containers, Docker itself starts to fall down, and that's where you have to go into container orchestration engines. Cool. Yep.
Didn't quite touch upon this, but I'm just kind of curious your experiences when it comes to workflow and like syncing files, right? Local development within the container. I've been using like Docker Sync, but it has a lot of problems on the Mac, and sometimes the sync doesn't actually do its job effectively.
Are you talking about trying to have the source code from the Docker file come from your local machine?
Yeah, I was just curious if you had any.
Yeah, I use mounted volumes for that. So basically, in your Docker Compose file, so just say for my front end code, I wanted to do this, I would basically go volumes, and then I would map the, it was the source folder, and I would map that back to my source folder in my front end, so that would be this folder. So it'd be basically source, something like that. So basically what that would do is, what it does is it makes that folder inside the container come from your laptop. And that way if you change the source code, it automatically, the source code running inside your container is the source code that came from your computer because the drives are mapped. I probably have the syntax wrong, you can look it up, but that's how I do it generally. And then you can do hot reloading of the containers, and then you get all your hot reloading then. So when and then you just have to make sure that in your Docker file, so I've got like HTTP server dist, you just have to run a dev build in there, and then anytime you change the source code, the container will change, because it is the same folder. So mapping volumes works for database data files. It also works for source code. So I got that trick from Michael Herman's class. So do the class. It's very good. I've only met the guy once. Really like him. Who here actually knows him and was trained by him? No?
I know him.
Yeah. He's one of the trainers at Galvanize.
I bought his course already. I just haven't gone through it.
Yeah, it's a good course.
Let's do one more question. Anybody?
0 is a good number.
I'll go.
Ah, seriously. It's always 1.
I'm just curious, you kind of already hit this, but what's the major downside to Docker?
It's easy till you have to put it in production. Yeah, no, Docker's awesome. If you're not using it, you've got rocks in your head in my view now. I wouldn't do any project without it. If somebody told me to run a Maven build and then deploy the source code directly onto an EC2 instance, I'd just probably quit. You'd be nuts to develop any other way. But getting into production just sucks. There's no, it sounds awesome right up until you really have to set it all up, and it's really fiddly. And way more time consuming than it needs to be. Rancher, honestly, out of all the engines, kind of the one I like the most so far. It's basically Kubernetes, but as I found out, not everything runs nice in Rancher, and it's expensive to run, and there's no cheap way to experiment with it. So I'd still probably just do everything in Docker Compose and then publish it to ECS.
Would you put 20% onto your project just to get into production?
Depends on the project. I'm gonna hide the badge for the company that I'm working with right now. But yeah, I would allocate a lot of time for. It speeds you all up a lot during the development cycle, and it slows you a lot down during the launching cycle. And things you think will work don't when you're trying to run an orchestration engine. So we've already gone through 3 different orchestration engines, and we went back to the first one because AWS patched ECS. So if we didn't have that patch in ECS, we would have had to run our own native Kubernetes cluster. So it's so luckily it works, but yeah, it's non-trivial. Yeah. Cool. All right, thanks, folks.
We'll be hanging around for a little bit if you want to ask further questions or just chat. If not, hope to see you next time.
Nice. Good job. Nice. Yeah, doing dinner in the middle was a bit weird, but.
Well, you got to roll with it.
Yeah, that was fun.
Yeah. Not exactly the way I had it planned, but
Yeah, I know.
shit goes south every once in a while.
So we started 6:30, finished 8:15, but did dinner in the middle.
Yeah. So
So probably about 70 minutes for the talk then.
Yeah, and that's about what we're averaging. It's tough to eat, there's usually some kind of spillover.
Yeah. Hey,
Hi, I'm Brooke.
nice to meet you.
Thank you. That was great.
Thank you.
I'm kind of in the early stages, so this is great to get into. But I was curious, on top of the other resources that you mentioned there, is there anything in the community you're following, right? Like some of the community resources, blogs, stuff that you like, this is where you should be tuned into.
No.
Community movement, stuff like that.
Not really. I've done a ton of Kubernetes courses, and they all suck except for that one.
Okay.
That one's awesome.
Okay.
all the rest of them were like, ugh. Anything from the Rancher folks, for whatever reason, is pretty awesome. They've got a lot of really good stuff about running Kubernetes Minikube locally for development. Their blogs and their YouTube videos have by far and away been the best. So, other than anything written by the Rancher folks is good. For the project I'm on right now, we literally didn't have a solution because we're load balancing UDP traffic, which nothing can do except for Nginx. If it wasn't for the Rancher folks being super helpful, we wouldn't have had a solution for how to do it. And then in the middle of all of that, ECS came through and patched a few services and gave us something that we could use. So we've gone back to ECS because we really didn't want to run a Kubernetes cluster with an Nginx ingress router. That would have sucked. But I don't know. If you do any of the AWS courses or reading any of the material, it's all just rah, 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 AWS, yay. And everything sounds awesome until you try to use it. And then, if you start searching on AWS on Google, everything points back to AWS resources. There's not a lot of people saying, hey, here's where all the sharp edges are. There's not a lot of documentation around that. Like, you have to just go try it. But everything from the Rancher folks is great. I didn't play around with DCOS, like Mesosphere. Like, we talked to their reps, like, kind of know how it works, but I haven't actually played with that for real. So I haven't really, but the main thing is just read the blog posts from the Rancher guys are great. That class is great, that class is great. I've done probably 10 other ones that just were like, those two along with the Rancher talk on Docker networking is probably the best thing I got, but that Michael Herman's class covers everything you would ever need to do. He runs big Kubernetes. I went to his Kubernetes talk like 2 months ago at the Denver Boulder Node developers thing, and he covered Kubernetes. It's pretty clear he knows how to run that at scale too, and knows what he's doing. And he teaches classes on that, I believe, or at least they use it. So his course is very comprehensive for the end-to-end workflow, and that's where things like hot reloading of code, that's where I learned all of that stuff. Like, I never would have thought of that on my own. And it's not in the Docker Hub docs. The Docker Hub docs are great too. But that's all I got. Like, I just watch lots of YouTube videos and of people at Netflix, and Google and how they did containers and microservices. All those talks actually from the Netflix container orchestration at scale. That's awesome too. That's a really good video. They talk about Chaos Monkey, how they actually scaled their services over time.